Hello and namaste everybody. In this video I am going to show you how to make use of NEC software. This software is freely available on the internet and is a dedicated software to design and analyze wire antenna only. So this is the NEC software. Click on it. This is the main window of the software. Before simulating any antenna, you have to set its reference impedance. So click on setting, select characteristic impedance. This characteristic impedance is the impedance given to a source which is used to excite the antenna. So here you can see that characteristic impedance chosen is 50 ohm. It means that the antenna will be analyzed with respect to 50 ohm. But if suppose you want to analyze your antenna with respect to some other impedance, then this value can be changed. Since I'm going to simulate dipole antenna and the simulation of the dipole antenna will be done with respect to a reference impedance of 50 ohm, so I will not change this value. I will keep it as it is. Now in order to create the geometry, go to the setting option once again and select geometry edit. Now click on NEC editor tab. This takes you to a new window. Here you can see that already one structure is existing. Now if suppose you want to create a new structure, then go to the file, click on new. Before creating any structure, you have to select appropriate planes. Here you have the option of XZ plane, YZ plane and XY plane, and whatever structure you will be creating, that can be seen in its 3D view also. So whenever you want to see the actual view of your antenna in 3D world, then this 3D option can be selected. Now I'm going to create a dipole antenna and it will be placed along Z axis, so I can choose XZ plane or YZ plane. So let us consider that I have chosen this XZ plane. Before creating any antenna, you should be ready with its all dimensions with respect to a frequency. Now before creating the structure, you have to feed the reference frequency. So since I'm going to analyze the antenna at 2400 megahertz, so I will feed that 2400 megahertz, and do not forget to press enter key. Now I have chosen frequency 2400 megahertz. Next target is to create the structure. Since this software is dedicated for the wire antenna, then you can see that this tab, it represents a wire geometry. So click on it. Now this wire should be added along the Z axis, so click on add tab. Now in order to create the structure along the Z axis, just place your cursor at any point on the Z axis, press left key of your mouse. Without releasing the key, drag the mouse and take it on the negative side of the Z axis and release the key. Now the software asks you to feed the radius of the wire. So let us consider that I have chosen 0.5 mm as radius of the wire antenna. Press enter. So now you can see that a wire of 0.5 mm and certain length has got created. Now as I said that you have to ready with the dimensions of the antenna, which is totally dependent on the frequency chosen. So at 2400 megahertz, the free space wavelength will be 0.125 meter, and since you are going to create a dipole antenna, so length of the dipole antenna is always lambda by 2, so the length becomes 0.0625 meter. But instead of taking it as 0.0625 meter as it is, we will take 90% of the calculated length, because the calculated length is nothing but free space wavelength. So always take 90% of the calculated wavelength. So 90% of the calculated wavelength, that is lambda by 2, it is approximately 0.057 meter. Now I will place this dipole antenna symmetrically along the Z axis, that is half of the dipole along the positive Z axis and half of the dipole along the negative Z axis. Now since this wire is appearing in as red in color, it means that it is in selected mode. So if suppose I click somewhere on the XZ plane, then the antenna, it gets deselected, and you can see that the options available here that has got disappeared. So in order to select the wire, you click on this arrow button and click on this wire. So all these buttons which are available on the right hand side, it shows the each and every information related to the structure which you have created here. So here you can see that this is end 1 of the wire and this is the end 2 of the wire. So here it is X coordinate, Y coordinate, Z coordinate. This is the end 1, means the top one. You can see that if this is the Z and it is positive, it means that it is the upper point of the created structure, and this is minus Z, so it is the lower end, that is the end 2. And since the antenna is placed along Z axis, that's why X and Y components both are 0. Now since the antenna is placed symmetrically along the Z axis and the length of the antenna is 0.057 meter, so I will feed here positive Z coordinate. It is going to be half of that 0.057, so it is going to be 0.0285, and on the lower side it is minus 0.0285. Now the total of this becomes 0.057, which is nothing but 90% of lambda by 2 length. Press enter button. Before assigning any source to the created structure, it is always to divide the created structure in number of pieces. So for that, here you can see that segment information is there. It means that you divide your structure in multiple segments. So let us consider that I divide the created structure in 100 pieces. In order to check whether the division is done or not, you can check this segment option. So you can see that your antenna is now segmented and the number of segments are 100. This is done to get the accurate result. If you are not doing this, then the result may deviate from the actual result. That's why always do the segmentation. But higher segmentation is going to take longer time by the software to simulate that particular structure. Now the segmentation is done. Once again, just I will uncheck this so that I can see a smooth wire here. Now it's time to assign a source in order to simulate the antenna. So this is the source tab. Click on it and click on add button, because you are going to add source to this wire. Now the reference impedance of the source, it was already chosen as 50 ohm. It means that you are going to add a 50 ohm source to this antenna. Now the feed is always connected at the midpoint of the dipole antenna, so this is the midpoint. Now in order to add this source, just place the cursor at positive Z point and drag the mouse without releasing the key, and release the key when you have reached to the center of the wire. Now the source is ready. Now click on Run tab. A new window pops up. Here you can see multiple options are there, and as per the requirement you can select any of these options. For example, if you're interested to check the radiation pattern of the antenna at a particular frequency, then far field option can be selected. Similarly, if you're interested to analyze the near field behavior of the antenna, then near field option can be selected. Now the frequency sweep option can be selected if you're interested to see the frequency response of the antenna. So we'll begin with the frequency sweep option. The moment you click the frequency sweep option, the software asks for the start frequency and stop frequency, and along with this it also asks for the step. Start frequency should be less than the center frequency, that is the frequency at which you have designed the antenna, and the stop frequency should be larger than the center frequency. Step frequency is the distance between the two consecutive frequencies. For example, if the first frequency is 2200 MHz, then the next frequency after this will be 2202 MHz, and next to this will be 2204 MHz. If suppose you change the step size to 4, then after this first frequency, that is the start frequency, the next frequency will be 2204 MHz. Now click on generate. Click OK. Now this is the frequency versus SWR and frequency versus reflection coefficient graph. These two graphs will help us to understand for what band this antenna is going to work. You can see that the center frequency of the antenna is 2400 megahertz. So what can be the lowest possible or lowest allowed frequency and the highest allowed frequency, that is the bandwidth of the antenna. So in order to do that, you need to have certain information related to the SWR or the reflection coefficient in dB. The worst case for SWR is 2. That is the maximum allowed value in practical world. So you select a frequency where the SWR is close to 2 or exactly 2. So here you can see at 2280 megahertz the SWR is 2 and the reflection coefficient is minus 9.52, or around you can say it is minus 10 dB. So this is your lower frequency of the antenna, 2280. Now in order to find out the upper frequency, you have to click, or you have to find out the second location where the SWR is nearly 2 or exactly equals to 2. You can use left and right key from your keyboard. So now you can see that this is the second frequency where the SWR is 2. It is 2542. So the second frequency is 2542 megahertz. In order to find out the bandwidth of the antenna, you have to subtract the earlier frequency where SWR was 2 from this 2542 megahertz. So it becomes 262 megahertz. So if you calculate the percentage bandwidth of the frequency, then it is coming around 10%. And you can see that at the resonant frequency, that is the desired frequency of 2400 megahertz, the SWR is minimum and it is 1.4. Second approach to find out the operational bandwidth, you can take the help of reflection coefficient in dB. So you have to search for two different locations where the reflection coefficient is around minus 10 dB, approximately minus 10 dB or minus 9.5 dB. So if you select a cursor, then minus 9.5 dB is coming at 2280 megahertz, and similarly on the upper side it is going to be 9.5, so it is 2542. So whichever approach you use, the bandwidth of the antenna is not going to change. So the dipole or the simulated dipole has a bandwidth of 262 megahertz. This is all about the frequency response of the antenna. Now we'll see the radiation behavior of the antenna in open space. For that, select Geometry window, click on Run tab. Now select Far Field Pattern. Here you have to select a frequency at which you want to analyze the radiation behavior of the antenna. Since the antenna is designed at 2400 megahertz, so let this figure be as it is, that is 2400 megahertz. Now click on Generate. Click OK. This is the two-dimensional radiation pattern of the dipole antenna, but it is always better to start with three-dimensional radiation pattern of the antenna. So for that, click on Main window. In that, click on 3D Viewer tab. So this is the antenna 3D view of the created structure. So here structure related drop downs are available. Here pattern related drop down and gain related drop down buttons are available. Since we are interested in the pattern, so I will select the middle drop down, and from that click on multicolor. So this is the radiation pattern of the antenna, and you can see that this represents the gain of the antenna, and every color has got certain value. So you can see that the pink color has got the largest value. It means that the antenna has got maximum gain in this particular region, and it is 2.13 dB. Here there is same radiation pattern but in two-dimensional world. Or you can see that this is z x or z y plane. Means if the antenna is kept like this. So this is the 3D view, and if the similar antenna or that antenna is analyzed, its radiation pattern is analyzed in two-dimensional world, then the shape of the radiation will look like this. Just click on any point on this radiation pattern. So at 90 degree if you are clicking, then the gain is what? 2.13 dB, because this 90 degree means what? This pink region only, and which has got 2.13 dB color. Now in order to find out beam width of the dipole antenna, then you have to click on the radiation pattern where the gain drops by 3 dB. So 2.13 dB gain minus 3 dB, so it comes around minus 0.87. This point is very close to minus 0.17. So here it's 50 degree. Now the angular separation from 90 degree to this 3 dB point is 40 degree. So this 40 degree, and similarly on the lower hand side it is going to be 40 degree once again. So total angular separation is around 80 degree, 40 degree from here to here and 40 degree from here to here. So the beam width of the dipole antenna is 80 degree, and the maximum gain of the antenna is 2.13 dB. That's all about how to use NEC software to create a particular structure and analysis of that structure. Thank you for watching the video.